Okay, welcome to the class of additional mathematics. With me here is the question, which is coming from the past paper 1, 2024. And this question was number 5. Okay, so now let us see how we are going to handle this particular question. But remember, I always emphasize that whenever you have a question, make sure you identify the topic of that particular question. Okay, so this question that we have here, when you look at it, this question is coming from the circle measures, okay? Measures of circle, okay? Where sectors and arc are being calculated. So this is the question. It is coming from that same topic. So now, we can, now that we've understood, identify the topic where the question is coming from, it is going to be very easy for us now to know how to go about that particular question, bearing in our mind the actual topic of the same question. So let us actually go through the question and see how best we can answer this particular question. In the diagram, OA, which is OA, is a sector of a circle center O. So the center is here, okay? And radius 5 centimeters. Radius from here up to here. That is the radius because this is a circle, the center of the circle, okay? So we are assuming this circle is like this, okay? Now only this part has been mentioned. So this is our center. Then AF, where is AF? F is here, okay? I didn't just indicate it. AF is equals to CD, okay? CD, where is CD? C is here. CD, this is D, okay? CD, then is equals to 2 centimeters. So it means from here up to here is 2 centimeters. Then from here up to there is also 2 centimeters. Then DE is equals to EF, which is also 2 centimeters. So from here up to here, 2 centimeters. From here up to there, 2 centimeters. And OB intersects DF, okay? Intersects DF. That one has been intersected. DF at 90 degree, which is this one. 90 degree at E. This is point A. Okay. So let us now see how the questions was actually phrased. So here we are saying find the A value of theta in radians. Okay. B length of arc AC. So the arc is this one. Okay. AC. So we are actually looking for two things here. The theta, which is this one, okay? Then the arc, which is AC. Let us now see how we can answer this particular question. Solution. Okay. So to start with A, the value of theta in radians, this angle, it's the one which they want us to do what? To find. Now, when we look at this angle, this is 90, okay? This is 90 degree. So we are going to make a right angled what? Triangle. So a right angled triangle now, we can use SOHCAHTOA for us to find this angle which is A, okay? SOHCAHTOA, okay? Remember, this is the what? The hypotenuse, okay? And this is the opposite, depending on the angle where it is. So angle is here. So the opposite is this one, and the other one is the adjacent. Are we together? So now from there, we are going to use SOHCAHTOA for us to find this angle. Remember, the particular angle that you are going to find, we should convert it into what? Radians. So now, we are going to say SOHCAHTOA. So let us use sine. Because for sine, we are actually given this one, which is the opposite, because sign states that opposite of what? Adjacent. Okay, that is sign. Opposite over adjacent. Okay, opposite over adjacent. So it will be O over H. Okay, so now the opposite we have, and it is very easy for us to find the what? The hypotenuse in this case. Why? Because we are given OA, which is 5 centimeters. That is the radius. So now, if this is 5 centimeters, and we are saying AF in the question is 2 centimeters. So for us to know OF, we have to subtract 5 minus 2. Okay, so we are going to say 5 minus 2, and the answer will be 3. So therefore, our hypotenuse is what? 3. Our hypotenuse is 3. Okay, our hypotenuse is 3. So now we are going to say sine theta is equals to, now what about the opposite? Opposite is 2 from here up to there. Okay, is 2. We are given it's there. So we are going to say 2 over 3. Okay, now remember, we are looking for what? For theta, which is this one. Okay, so how are we going to do it now? So we are going to say theta equals sine, we shift the inverse of sine there, then 2 over 3. Okay, so what we are going to do here, we are going to shift the calculator. So sine, shift, then you shift, you click sine. Then from there, you are going to write the numbers that we have there, 2 over 3. 2 over 3. The answer that you are going to have is 41.8 degree. Okay, so that is our theta in degrees. Now remember, the question said you have to write in what? Theta in what? In radians. So let us now convert this one into radians. Okay, so what it is here is 1 degree is equals to pi over 180 rad. Okay, rad. So now let us convert. So now that we have 41.8 degree. What about the rad here? We don't know. We are going to put x. Okay, we are going to put x. So now what we are trying to do here is to find the value of x. That will be this angle into what? Radian. So here we are going to cross multiply. Cross multiply. 1 times x, it's x. Then 41 times 41.8 times theta over, we are trying to convert that one, times theta over 180. The answer is 0.72, or let me just round off, 3 rad. Okay, therefore our theta here is equals to 0.73 rad, or radian. Okay, so that is our theta. Yes, so we are done with the question A. Then we go to question what? B. Length of arc AC. Okay, length of arc AC. So now the formula for the arc, okay, length of an arc, the formula goes like this. First of all, we are going to get the standard formula of finding the theta. So theta is equals to arc over radius. Okay, now remember, in this case we want to find what? We want to find arc, the length of an arc. So it is going to be arc, the length of an arc is equals to, we are going to multiply the theta times radius. That will be the formula. Are we together? Yes. So now from there, we are going to say now, since this arc, if you can see the angle that subtend to this arc is the O of this angle. And remember, this line has cut the sector in halves. Okay? So if here we have 0.73, even this other one is 0.73. So now for us to find the O theta here, we have now to multiply this 0.73 right times 2. Okay? That is the one we are going to use on this theta, because the arc that we are looking for is actually cutting the O of this angle. Okay? So now we are going to say 0.73 times 2. What is the answer? So times 2. The answer is going to be 1.46. We are going to round off. Okay? So 1.46 right is the one that we are going to substitute where there is a theta when finding the length of an arc. So we are going to say arc, the length of an arc is equals to, our theta is 1.46 times, what is our radius? Our radius is 5 centimeters. This is what they have given us. Okay? Radius is what? 5 centimeters. So times what? Times 5. So now when we multiply this, what are we going to have? The answer is going to be 7.3 centimeters. Okay, these are the units, centimeters. So now, if you can see, we have centimeters. No wonder why even on arc we have actually put centimeters as our unit. So now, this is how we find the length of an arc. So, according to the question that we are given, the distance from here up to C is 7.3 centimeters. Thank you so very much for following. We have just come to the end of our today's lesson. The best you can do as a learner, make sure you go through this lesson, and where you feel you'll have a question, you are free to ask within the classroom of what? Additional mathematics. Thank you so very much. Bye.